All right. Standard normal curve. We're doing the SAT scores. Problem is check your understanding, page 242. First thing you got to do is make the curve symmetric on both sides. Line in the middle, which is your mean or mu up there, which is 502. Then you draw lines at the ends, and then cut it into 3 equal spaces on each side. To get the values for that, you will use the standard deviation. So you will subtract the standard deviation to go to the left. The standard deviation is 113. So this will be 389 and 276 and 163. Add the standard deviation to go up, so this will be 615, 728, and 841. Let's see, B, what is the percentage between 389 and 615? 389 and 615. That is between 1 standard deviation below and 1 standard deviation above. So the 68, 95, 99.7 rule says that it will be 68%. C, what is the percentage over 615? So that is 1 standard deviation above and above that. All right, so you take your 100, the 68, 95, 99.7 rule says 1 standard deviation is 68. That gives me 32 that's left. So what I did there was I took away this middle section, the one written in red. Took away the red section. This will give me what is left, so the tail on the left and on the right. Since we only want to know above 1 standard deviation, we need only half of that. And this graph is nice and symmetric, so 32 divided by 2 will give me 16%. So this section here is 16%. Okay, as we continue, we're going to do one on page 243, and we're going to calculate their height and their standard deviations. So a man's mean height is 68.5 inches, and his standard deviation is 2.7 inches. Marvin has a z-score, or a standard deviation, of 2.1 below the mean, so that is a negative. If we drew a nice curve real quick, you've got your mean there, 3 equal sections, and Marvin would be located 2 standard deviations below the mean at 68.5. All right, so to calculate his height, you will take the formula z-score multiplied by the standard deviation and add the mean. So negative 2.1 multiplied by the standard deviation 2.7 and add 68.5. I get 62.8 inches. 62.8 inches is how tall Marvin is. Let's check our work here. He should be where that red X is. So does that make sense? 68.5 minus the standard deviation of 2.7 gives me 65.8 there. Minus another standard deviation gives me 63.1. He should be a little bit less than that. He's 62.8 inches. Looks good to me. All right, D. We've got Miguel, who is 74 inches tall. So that's a data value. 74 inches tall. Same information, same curve above. If we want to figure out a z-score, we will have to take the formula, data, divided or minus the mean, divided by the standard deviation. So 74 minus 68.5. Make sure you hit enter. Then divide by 5.5. Oh, I'm sorry. Nope. Standard deviation, let's see, is 2.7. Divide by 2.7. And I get 2.0. One place after the decimal will be sufficient. 2.0 above. Again, let's double check that. I'll do that in blue. 3 marks. There we go. 68.5 plus the standard deviation of 2.7. 71.2 plus another standard deviation, 73.9. That's 2 standard deviations above. That's what he was, 74 inches, 73.9 inches, approximately the same. Looks good. Okay, here we go. Page 246 on how to use the table. We have the women and the mean and standard deviation and curves already there. B, Jackie is 62 inches tall, and we want to find her percentile. Okay, so 62 inches, therefore it has to be a data value because it's inches. So to calculate the z-score, 62 minus 65.5 divided by 2.5. You must always go from the data value to the z-score, which is negative 1.4. So let's put her on our graph, 1.4 down. So she's somewhere around there. Percentile, then to go, this is a z-score. Z-scores are always between negative 3 and positive 3. Then to look up the percentile, you just take the table, look at a z of negative 1.4. And I've got 0.08, so 8.08%. She is taller than 8% of the population. C, now they want to find the percentage between Abby and Jackie. Well, Abby, this was Jackie, Abby is 68 inches, so got to calculate that. 2.5. I have a z-score of 1. A z-score of 1 gives me a percentage below of 84.3. 13, sorry. And if you want the percent between, let's see, z-score of 1, she's right there. If you want the percent between those two, you just subtract the numbers, largest number first, so that we can stay with positive values, because a negative percentage doesn't make any sense. I've got 76%. So 76% of the women population is between Jackie and Abby. Now going in the other direction, let's do E, sorry, E. We've got Yvette, who is in the 31st percentile, 31st percent. Percentile is how many people are below, percentage below. That's what's on the table. So look up approximately 31%, which is approximately 0.3. Oh, what's the best we could do? 0.3085. 3085. I forgot to look at the z-score. Hold on. Z-score of negative 0.5. And then if that's my z-score, then to calculate the data value, the inches, I will take my z-score, multiply it by the standard deviation, and add the mean. So negative 0.5 times 2.5 plus 65.5 is 64.25 inches. Let's do this in red. Let's double check our answer. Z-score of negative 0.5 would put her right about there. And is that about 64 inches? Yes, between 63 and 65, 64. So it looks good.